Hi, this is Lab 4 covering oscillations. The goal of this lab was to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. In the end, we predicted the motion with a computational model that closely matches the actual model, and we determined that the spring systems satisfy and represent the energy principle, as you can see, as the total energy remained constant. Several principles were used throughout this lab. The first one was Newton's second law. We used this to find the mass's velocity, which then enabled us to find the kinetic energy of the mass. Then we also used the energy principle, which says the change in energy is equal to the work done on the system plus the heat transferred. But since there's no work done on the system and no heat was transferred, the change in energy is just 0 joules. The change in energy was equal to the change in kinetic energy plus the change in potential energy. But there are two potential energies in this lab. There is the gravitational potential energy and the spring potential energy. But when you add the kinetic and both potential energies, it is still 0 joules. The spring force is equal to the gravitational force, and when you expand this, it's the spring constant times L minus L naught is equal to mass times the acceleration due to gravity. Several equations were used throughout this lab that dealt with the period, the force of the spring, the force of gravity, the kinetic energy, and the gravitational potential energy, as well as the spring potential energy. However, we need to expand the spring potential energy and solve for its components because we don't know the spring constant as well as L naught. One of the components I had to solve for the spring potential energy was the spring constant. I used the equation for a period and manipulated it so that way the spring constant equals 4 pi squared times the mass over the period squared. So this means we had to find the period. So using the tracker data, I was able to find that the period is equal to 1.61 seconds, and then when I plugged this into the equation, I found that the spring constant was equal to 6.12 newtons per meter. The next step was to find L naught. L naught is equal to the magnitude of L minus the mass times the acceleration due to gravity divided by the spring constant. So we have all our givens. We had the magnitude of L, which is equal to 0.7 meters. We are given the mass. The acceleration due to gravity is a constant, 9.8 meters per second squared. We just solved for the spring constant, which is 6.12 newtons per meter. Then, when we plugged all this into our equation, we were able to find that L naught is equal to 0.056 meters. There are several energies in the system. There is kinetic energy, which we were able to find by using Newton's second law to solve for the velocity of the mass. We had the gravitational potential energy, which we were able to solve for since we had all these components. And then we just solved for the spring potential energy of the system. There are two forces acting on the mass. There's the force of gravity and the spring force. The net force is just the sum of the two forces. We have the equation for the mass's velocity, which lets us determine its kinetic energy. Then we also have the equation for the mass's position. This lets us compare the actual model's positions versus the predicted model's positions. In the end, the yellow line represents the total energy of the model. As you can see, it remains constant at 0 joules, meaning energy is neither gained or lost. Here, there is a black arrow representing the gravitational force. It remains constant throughout the entire model. However, the blue arrow represents a spring force, which does not remain constant as S changes. The blue ball represents the predicted model's positions, and the red ball represents the actual model positions. When the computational model is run, there is a slight difference between the two, because in the actual model, there are forces that we did not take into account, such as drag. The first what does it mean question asks if the energy principle is satisfied in the model. It is, since the yellow line remains constant at 0 joules. So, therefore, energy is not lost or gained. It is simply converted from one form to another. So it is converted from gravitational potential energy to the spring potential energy and to kinetic energy. The second what is a mean question asked for the period in the x and y direction. The period in the x direction was found just like it was for the y direction with our tracker data. The period in the x direction was 1.61 seconds, and in the y direction it was 1.23 seconds. As you can see, they are not the same. This is because the mass is moving in 2 dimensions and therefore has 2 different periods for these directions. In conclusion, the law of conservation of energy says that energy can neither be created nor destroyed. It can only be converted from one form to another, as we saw with our model.